Hello again everyone, welcome back to ptet.chemistry channel. So this is video number 5 of 10 in this series into infographics that are provided by Cambridge International. So I don't come up with this infographic, they do. So they provided for free during the pandemic period on their Resource Plus website, which I was able to access, and I have a copy of it, which I put down in a Google Drive link in the video description below if you wish to use that for your teaching, or just to I don't know, if you're interested in these infographics. So what this is that this is not a complete overview of your syllabus or specification. Indeed, for that you have to refer to your specification or syllabus document exactly, so that you make sure that you're not missing anything. But what this is trying to show you the relationship between the different things that you'll be expected to know. So for this thing is about chemical trend in A-level chemistry. In fact, in most chemistry courses, this is what we term as periodicity. So it's what happens down a group or across a period, or what classify as how we classify together a period of elements like transition metals. Why are they called transition metals? Why are some stuff S block elements? Why are some stuff P block elements, etc., etc. What this is not, however, is not a tutorial playlist. So if you are not into this kind of thing, you can by all means skip straight to the other tutorial playlist, where I have component paper tutorials for those who are doing the Cambridge International. Or you can simply just go topic by topic, where I also have topical playlists for A-level chemistry to help those doing whatever other examination board there is, because they will be suitable regardless. Yeah. So in this 9.1 is saying that period 3 elements. So this is about the elements, whereas in the next bit 9.2 they're talking about the oxide, and then they talk about the chloride. Okay, so the elements, the oxide and the chloride, so period 3, they constitute part of the case study in your A-level chemistry. So these values are just given for representative purpose. There's no way you'll be expected to remember the values, yeah? But what's interesting for you to know is that group 1 metal does have a quite low melting point. Actually, that is below water. So sodium actually melts below water. But regardless, it's still a metal, and they do have metallic bonding within them, whereas silicon is giant molecular solid at room temperature and pressure. So you see the very high melting point there, and all these are simple molecular. In fact, this is also simple molecular, but argon exists as a single atom, monoatomic. Of course, the oxides and the chlorides, we can talk about the structure and bonding as well. It is interesting that here you have the SO2 and SO3, sulfur and +4, sulfur and +6 oxidation state. But here you are just given P4 or 10, rather than being given the option of P4 or 6, which is phosphorus +3. So I think the reason why they don't give you the phosphorus +3, which is P4 or 6 there, is that it can be quite hard to actually stop at P4 or 6 in terms of the oxidation. So if you have if I start from the molecule, which is P4 plus O2, I need exactly 3 equivalent of oxygen. If I have excess oxygen, it can go to P4 or 10 very easily. Whereas sulfur burns in oxygen to give you SO2, but it doesn't go to SO3 readily. If you remember your contact process, the reversible step is the one from SO2 to SO3. That doesn't happen unless you have a catalyst and all those reaction conditions in your man-made factory style kind of conditions, or unless you're in the upper part of the atmosphere where oxide of nitrogen can catalyze the reaction. So those constitute part of that environmental chemistry, nitrogen and sulfur topics in the topical playlist, and you can find out more about them, where they always like to ask the environmental chemistry side of it. Yeah. The next section, they combined and relate that to the periodic trend on in the energy levels, atomic orbitals, ionization energy, and electron affinity. So this actually relates early on from your specification. You will have been taught about this before structure and bonding, because we talk about nuclear charge, the charge due to the protons in the nucleus. We talk about shielding, where it changes across a period, where it changes down the group and how they change. And then we talk about the net effect, which is the effective nuclear charge. And all of these are used to explain ionization energy, electron affinity, which you cover in A2 chemistry, or depending on whatever specification you're doing, they might have been in your AS chemistry together with ionization energy. And then it also explains about the atomic radii, so they don't mention it there, but it affects atomic and ionic radii as well. They affect electronegativity as well, so things that we talk about in structure and bonding. And of course, your periodic table actually, you can use your periodic table to work out the electronic configuration, etc., because you fill in based on the difference in energy levels. In terms of chemical periodicity of other elements, so this is another period of elements, but as we know, the chemical reactivity is governed by the number of electrons in your outermost shell. So group 1 metals have similar property between sodium and rubidium because they all have 1 electron in the outermost shell. So therefore, we expect rubidium to show similar reactivity as sodium, as potassium, etc. Okay. Group 2 is a big part of your A-level chemistry, where in AS they ask you simple things like the group 2 oxide, M plus O2 minus, M2 plus because it is group 2, so M2 plus, OH minus, which means you need 2 of the OH minus to balance out the charge. And then you also have the carbonate. So the diagram is a bit small here, but it's talking about the thermal stability of the carbonate. It's talking about the thermal stability of the nitrate. The solubility of the hydroxide and the sulfate differs oppositely, but I know the barium sulfate from doing a lot of your practical, you know that is insoluble. And you also know that magnesium hydroxide, or looking at calcium hydroxide, which is lime water, they are sparingly soluble, whereas barium hydroxide very soluble because strong base, that is around pH 13 or 14, whereas when you look at magnesium hydroxide, we are looking at around pH 9 because this is more soluble than the magnesium hydroxide, because solubility of group 2 hydroxide increases down the group, they become more alkaline. Okay, magnesium sulfate is just sparingly soluble in water. They don't show you the carbonate, but all the group 2 carbonates are almost insoluble in water. Okay, so in AS chemistry, you're expected to know the trend, stating the trend, and then in A2 chemistry, you're expected to apply more advanced concepts of energetics, as you can find out from my topical playlist on group 2, A2, group 2 chemistry. You'll be expected to know a couple of fixed assays, which will get easier if you know what you're talking about, so that you can tell the story on your own. Uses of calcium carbonate and calcium hydroxide are mainly used in agriculture to raise the pH of acidic soil. So acidic soil will have low pH. This is alkaline. This carbonate will help to neutralize the acid. This carbonate will react with the acid to give you salt, carbon dioxide and water. The hydroxide will neutralize the acid to give you salt and water. They will help to increase the pH of acidic soil. They will help to reduce the acidity of acidic soil. Okay. Group 17 is another big part of your A-level chemistry. So you start from fluorine, chlorine, bromine, iodine. S13, which is just below iodine, it's a radioactive element, so it's not very stable at room conditions at all. Yeah. In terms of the first property they look at, volatility, is to do with how easy to boil. So increased volatility means it's easier to boil. Okay, it's down to van der Waals forces, which a lot of students just remember as the total number of electrons, but they forget about the second thing, which is size or surface area of the XX molecule. So your size gets bigger, so your van der Waals gets stronger, But of course, people just remember the first factor, they forget about the second factor all the time. That is from the structure and bonding concept. Another thing you notice is that the color gets darker and darker down the group 17. We don't typically discuss fluorine chemistry as part of group 17 chemistry in A-level, but it doesn't mean they can't ask you anything about it, okay? And of course, you have the test for halide anion, which you have done since your GCSE or O-level. The different color of the precipitate by using silver nitrate, which is soluble. These are insoluble. And then when you add corn sulfuric acid, so they've done something very bad here. You should use corn sulfuric acid, which can be an acid, a strong acid, okay? It can also act as a oxidizing agent, okay? It's not for all of them, because here you see you only get acid-base reaction, but here you get acid-base reaction and you get redox. Whereas for Cl minus, you only get acid-base reaction, because we are looking at this scale of oxidizing power, where we have Cl2, Br2, I2, and where would your corn sulfuric acid lies? Your corn sulfuric acid lies in between there. You will see a lot of these in group 17 questions in my topical playlist. A lot of them are being asked around, they revolve around this particular simple diagram, where corn sulfuric acid is a stronger oxidizing agent than bromine and iodine, but weaker oxidizing agent than chlorine. So it cannot oxidize the Cl minus to Cl2. It only stops at acid-base reaction. There are then environmental consequences, environmental concerns on using halogenated compounds, and this relates well to your halogenoalkane chemistry. So this is a polymeric chain that contains halogen, and of course these are chlorofluorocarbons. Okay, burning this thing, we have to break the bond, and they can release toxic gases like HCl, corrosive gas as well. Okay, whereas this thing can be very damaging to our ozone layer. So the ozone layer protects us against the direct UV light from the sun. Yeah, this is exactly what I was talking about, the redox ability, whereas this one is about the thermal stability of the hydrogen halide. These are covalent bond. We are literally breaking the covalent bond here, so the bond gets shorter because the atom gets smaller, so the bond energy increase. You can quote and state the value from the data booklet, and they will affect the thermal stability. Okay, this is probably one of the most important key reactions. This is called disproportionation. This is chlorine minus 1, this is chlorine plus 1. Oh, okay, they already have it there. This chlorine minus 1, this is chlorine plus 5, there's 0 and 0. Sometimes they also call it sodium chlorate 5 in Roman numeral. And for this thing, they will call it sodium chlorate 1 in Roman numeral for the oxidation state. Okay, the conditions are important. So coal is around room temperature, 20-25 degrees Celsius. So room temperature is 25 degrees Celsius, but coal here is referred to like something very close to room temperature. Hot here is very easily achieved, like 60 degree, 50 degree. You can get this reaction happening fairly easily already. Okay. The chlorine is both oxidized and reduced. Chlorine is both oxidized and reduced. This constitutes part of your redox chemistry that involve using changes in oxidation number to help balance chemical equation. All right, they can ask you to balance the equation. They can ask state the oxidation number. They can ask you to do calculations, okay, based on using the balance equation. All right. The last bit of this periodicity chemistry, they only mention nitrogen here. In reality, we also have nitrogen and sulfur, and you have to relate that to environmental chemistry, and that's all in the nitrogen and sulfur playlist, because that is when they involve the formation of acid rain, where they can ask you in A2 as well as in AS mostly. Okay, so the use of excess nitrate lead to eutrophication. So there's a technical spelling. You should know the essay revolving around the processes of eutrophication, even from your O-level already. the unreactive nature of nitrogen molecule due to the strong triple bond, and why ammonia is important due to their importance in making nitrate fertilizer. Sorry, not nitrate fertilizer, not just nitrate fertilizer, but to make ammonia, so you can form fertilizer with it give you ammonium. Okay, from ammonia you can get ammonium, because this is a salt, this is a base. You can react with an acid to give you a salt, which you can use as a fertilizer. All right, this is an oxide of nitrogen. Notice that they have shown a 1 unpaired electron on the nitrogen, because NO is a radical. A free radical is a species with unpaired electron. When you think about it, the nitrogen, so they've shown it in such a way that there's always 1 unpaired electron on the nitrogen, and it makes it a radical. And oxides of nitrogen include NO2 as well as NO, and they can be formed inside a car engine when the nitrogen and triple bond in the air can be split and can be broken due to the high temperature produced by your car engine combustion. Yeah, and it also happens, they don't show it here, as you know, you can also split the nitrogen triple bond in nature as a result of lightning. There's enough energy there to split the nitrogen strong triple bond and lead to reaction. So this is the end of this just very simple topic linking together different topics and concepts in periodicity in A-level chemistry. By no means is the infographic complete, and by no means is the infographic representative of everything you need to know in your specification syllabus. What it does is it gives you a great overview of how the topics are linked together, and that's how chemistry is all about. It's not just an independent topic. Alright, so like I said, this is the 5th out of 10 video series, and yeah, catch me in more videos outlining these topic linkages. You can get the file from the Google Drive link in the video description below. Thank you for watching. Please subscribe to the channel if you haven't, and check out my other playlists if you think they are great, useful for you. Please share them with your friends, your class chat group, your students if you are a teacher, your teachers if you are students, so they can benefit more people.